Alright, gear up everyone, because today on STEAMspirations, we're diving headfirst into the world of Lego bricks. Well, kind of. Welcome back to STEAMspirations. Do you remember playing with Lego bricks as a kid? Picking out each unique piece, connecting them, and creating something awesome? Well, today's topic, object-oriented programming, or OOP for short, is kind of like building the Legos, only these bricks are virtual. Intrigued? Let's dive in. OOP isn't a fasting tool or a trendy app. It's not even a programming language. Instead, it's a foundation, the model, the game plan that some of our most loved programming languages stand on. Think of languages like C++, Python, and Java. All have OOP's fingerprints all over them. Why do we need OOP? Picture a spectrum. On one end, you've got the complex, incomprehensible language computers speak, all those zeros and ones. On the other, the easy everyday language we humans chat in, right smack in the middle. That's where programming language sit, acting as translators between humans and machines. But as we push technology's boundaries, we need better ways to communicate our ideas to the computer. Enter programming paradigms and models, like our star today, OOP. Instead of focusing on a jumble of functions and logic, OOP puts a spotlight on objects and data. It's all about seeing and coding these objects as they are in a real world. Imagine creating a program just like you set up a scene with your Lego set. Think of a class as your Lego brick mold. It decides the shape, size, and function of the brick. Once you've got that mold, also known as a class, you can churn out as many bricks, or in other words, objects as you want. For example, we can create a dog class like a mold to create different doggies. Here, we've created a class dog with a constructor that initializes the name and breed of the dog. It also has a method called bark that makes a dog say woof. Once you have a class, you can create objects from it. It's like using your Lego bricks to build a specific structure. Now, my dog and your dog are two separate instances or objects of the dog class. They each have their own name and breed. Remember how you inherited some traits from your parents? Thanks, Mom, for the curly hair. OOP's inheritance works the same way. One class can inherit goodies from another class, allowing us to reuse and organize code better. For example, our Golden Retriever class shown here borrowed the best from the dog class and added its own twist. Here, we've created a subclass called Golden Retriever that inherits from the dog class. This child class not only inherits all the methods and attributes from the parent class, but it also has a new method called fetch. This fetch method is exclusive to the Golden Retriever class. It wasn't in the dog class. And as you can see, we didn't have to write all of those methods and attributes again for the Golden Retriever class. This is an advantage of OOP. Now imagine having a universal remote that can control your TV, sound system, and even your lights. In OOP, this is like having different objects responding to the same command in their own unique way. For example, let's create some classes for cats and birds. In this example, we have two different classes, cat and bird, with a make sound method. But both cat and bird classes speak, but they do it in their own special language. When we call the let them speak function, it allows different objects to speak in their own way. Congratulations, you've just cracked open the world of object-oriented programming. The tools, classes, objects inheritance, and polymorphism are your key to creating amazing programs. Love this Lego-inspired tour through OOP? Smash that like button and share the video. And don't forget to subscribe for more fun tech insights. Hungry for a deeper dive into OOP? Comment below and let us know. Till next time, keep building your digital Lego masterpieces.